So here is the question of reduction formula, integration of cos power of mx and sin n nx dx. Okay, so for this we have solution. Let for this type of question, let I m comma n is equal to cos mx sin nx dx. Okay, so that means so we have to integrate this term. So this is the first term and this is the second term. So we have to integrate this by integration by parts term. Okay, so for this then cos mx, the integration of sin nx is cos nx by n minus. Okay, the integration of sin x is minus cos x. Okay, so it becomes now again minus, and the derivation of cos mx is m cos power of minus 1 m minus 1 x, and again the integration of sin x derivation is minus sin x, the derivation of cos x is okay sin x, and the integration of sin nx is cos n x by minus n dx. Okay, so this is the term we have get. So now okay, so it becomes minus cos mx cos nx by n minus, this is the constant term, so minus m by n is here, minus minus cancel out, so here is minus, so that means cos m minus 1 x and sin x cos n x dx. So this is the equation 1. So for this type of question we have formula sin n minus 1 x, or that is sin n x minus x. Okay, so for this we have formula is equal to sin nx cos x minus cos nx, sorry, cos nx and sin x. Okay, cos nx. So as in here we have in the question sin x cos nx. Okay, sin x cos nx, so that means cos x. So we get or cos nx sin x is equal to, this is term sin nx cos x minus sin n minus 1 x. Okay, so this is the term we have get here. So now we have again, so from equation 1 we get I m comma n is equal to minus cos mx cos nx by n minus m by n cos m minus 1 x, and here we have what we have sin nx cos x minus sin n minus 1 x. Okay, so this is the term we have get here, and here dx. Okay, so now that means, so it becomes minus cos mx cos nx by n minus m by n, and here we multiply this term, so it becomes, so here that means cos m minus 1 plus 1 means cos mx. So here when you multiply this and this term, is here is the base is same, so that means cos mx sin nx minus, and again it becomes when you multiply this term cos m minus 1 x sin n minus 1 x dx. Okay, so this is the term we have get here, so here it is dx. Okay, so here it is the term. Now again it becomes is equal to minus cos mx cos nx by n minus m by n. So this is the term here. So in the question we have again, so is here we let I m comma n is equal to cos mx sin nx. So yes, we have get same, so that means I m comma n plus m comma n is here we have multiplied the by m by n. Okay, so minus, so this is the, this term is reduced by 1 minus 1, so is here cos m minus 1 and sin n minus 1, so this term is reduced by 1, so that means I m minus 1 comma n minus 1. Okay, so here we have I m comma n. So here we have this term. So now again it becomes, so again we have here or I m comma n. So we'll take this term here plus m by n I m comma n is equal to minus cos mx cos nx cos nx by n plus m comma n m by n I m minus 1 n minus 1. Okay, so this is the term here. So we'll take common I comma n is I and here remains m comma n minus cos mx cos nx by n plus m by n I m minus 1 n minus 1. So it becomes I m comma n is equal to minus cos mx cos nx by m plus n plus m by m plus n I m minus 1 comma n minus 1, which is Q, which is required reduction formula. Is here we have I 1 plus m, so that means it becomes m plus n by n. So that means n here, this n and this n cancel out. So we have taken this m plus n here, m plus 1 remains, m plus n remains, so it comes here in the reciprocal. So this is the